Dylan, do you want to start? Just like quick intro, what you're working on.
So yeah, good to meet everyone here. Some of the familiar faces I've definitely seen. Illia, you're definitely the first time I've ever met you. Previously just came across with you on our East Ever. So hi guys, I'm Dylan Pond. So we are building a GNN using blockchain on-chain data. So we see it as a foundation model because at the end of the day, the most crypto-native data structure, 100% is not language data. In our views, and the entire on-chain space, the entire on-chain data is an open graph network, and we are developing a model and also a model technique to connect different other models, for example, language model or tree models, to decentralize this model development process. So at the end of the day, that's high level what we're developing at the moment.
Don, do you want to go next?
Sure. Hey, everybody. Some of you I know pretty well, some of you first time meeting you, but I'm Don. I'm the co-founder, CEO of Nevermind. We're building the AI payments protocol. So the way we see things, we believe we're witnessing the rise of a new consumer, trillions of AI agents, and that these agents are going to change commerce forever. So much so that we're branding this new evolution of commerce, AI commerce. And the way we see ourselves is sort of as the PayPal of AI, and that engine that's going to power AI commerce going forward. Really looking forward to the conversation today. Thank you for inviting me, and also looking forward to collaborating with Nir as we push the envelope on AI and Web3.
Jasper?
Hey everyone, I'm Jasper. I'm the CEO and co-founder of Hyperbolic. I graduated from Peking University with the highest honor student of the year, and then I finished my math PhD in Berkeley in just 2 years, which made me the fastest person to finish a PhD in the history of Berkeley, and also gave me the idea of the name of my future company, Hyperbolic, because I study hyperbolic geometry and topology. I won several gold medals in various mathematical competitions, and after graduation, I worked at Citadel Securities and Everlabs before founding Hyperbolics. At Hyperbolic, we have the mission to build a decentralized AI cloud to enable open access to AI. We're achieving this goal by solving 3 major problems. First, system. We're building a scalable system to aggregate global GPU compute and develop AI services to maximize the performance of any kind of GPUs, including NVIDIA GPU, AMD GPUs, and other GPUs. Second, verification. We want to make sure the outputs coming from the network are run on the correct AI model. And lastly, privacy. We want to protect users' data and privacy even when the requests are handled by a random third-party node.
Awesome. So yeah, I mean, I'm Illia. We have Alex here as well. We've worked on some AI stuff before. But yeah, really excited to have you here. And yeah, I mean, I kind of wanted to kick it off to talk a little bit about what we've seen in the news. This week been kind of wave of new announcement. Curious what you guys think, and I think interesting to contrast that with what we're working on, right, in kind of more open source AI space, right? How do you guys think about it, or what questions do you think are we should be discussing and kind of considering?
Yeah, actually, I have a thought on the comparison of open source and closed source. So on one hand, I gradually feel like we criticize OpenAI quite a lot because they have a closed source model architecture. But at the end of the day, I'm also thinking from a business perspective. So pretty much all the business model have seen, for example, all the open source models like Llama 3 or etc. The main focus of them, the reason why they can open source is because their business model is not for the model itself. It's really for maybe you might have want to onboard as many developers to contribute to the Facebook ecosystem, for example. So in that case, it makes sense for them to open source their model. But on the other hand, I've been thinking, is there, when we are talking about open source and a closed source, what we are really talking about is at the end of the day is a kind of like a format of a political correctness, or it's more like something we feel like this entire Web3 needs to be open source so we can provide the transparency. And also I understand lots of different projects that are working on providing verification of closed source models, for example. I'm generally just curious to learn more about different people's opinions, because as a model business for OpenAI, this entire business model is built on top of a model. So the model, they have to protect it just in case if they open source it, they probably, the evaluation will go to zero immediately overnight. So this is kind of my thoughts. And these days I've been thinking this quite a lot. Like when we are talking about open source and closed source, is this just a political view, or we think this is the right approach to open source everything?
Yeah, I mean, I can kick it off because I've been thinking about it a lot as well. I think there's a few kind of dimensions to think about, right? One is, there's actually a scientific paper called Sleeper Agents, but the one is like, what is actually open source AI, right? Actually, what we have right now is not really an open source, it's open parameters. It's actually as if you got an executable file from a producer and they said, we done everything correctly, this is a good model, just use it, right? So I actually think there is a need for knowing what data went into the model to really be able to kind of verify that this is indeed the model that kind of represents the decisions that you are looking for. And this spans from kind of when I worked at Google, we would make decisions on what data to not include, right? Because like on the internet, there's all kinds of crap, spam, but also just misinformation, conspiracy theories, etc. And so there is a decision somewhere to like, oh, we're not including QAnon websites, or we're not including Alex Jones websites, or, do we include Truth Social or not, and stuff like this, right? And like, as you make those decisions, you kind of affecting the outcome. And the other way works as well, right? If you want to affect the outcome, you will start, poisoning your data in such a way that when somebody uses it in specific context, the model will output something. And it's really hard to test that. So yeah, encouraged to check out the Sleeper Agent paper. Actually, Cameron shared with me. So that's kind of piece number one. Is like, the problem is because you don't know what data went into it, even if the model is open, but especially if you just, using its API, you have no idea what you're actually interacting with. Now, on a business model side, I mean, I don't think it's true to say that if you open source your code, then immediately your value goes to zero, right? I mean, for example, blockchain source code is open. Anybody can fork it. Like you can spin off a near fork right now while we're talking, but that doesn't make near to go to zero. Because there's brand, there's kind of users adopting, there's network effects, etc. And I think what we see with OpenAI is similar thing. Like right now, even though there's alternatives, and like it's kind of hard to say now which model. Like yes, GPT-4 generally is better, but at some things Claude is better, at some things Gemini is better. It's hard to say that okay, well now everybody switched away from it, because there is such a like brand awareness of this. And I mean, this is hypothesis obviously, but if they have opened the model, potentially there would have been a lot more people building on top of it and kind of contributing back to it, right? What we've seen with Llama. So that's kind of my opinion. One of the reasons they kind of sometimes use is that like, oh, it's dangerous for people to have this model. And I think that's the specific reason that I want to call out, because like I think it's kind of a weird way to justify a business decision. Again, like as a business decision, totally, it is a decision for them to make. But the danger specifically seems misguided because they're not a military operation, right? If somebody wants to break in and actually steal the weights, it's not like that hard. And B, like at the end, it's, you're able to kind of get to this level if you really need to, with enough investment. And I think kind of this is where we get into Web3. I think we should be preventing whatever the AI models are possibly can in a dangerous way do. We should be creating systems that are protecting against that versus try to pretty much limit what you can do with these models. But yeah, I mean, Jasper, you're working on verifiable compute, so I'm sure you're thinking a lot about this.
Yeah, I actually just posted a Twitter post yesterday talking about this. So if you look at the news, like Gemini, right? Like people criticize about the pictures that the AI model generated. Like it's about races, it's about genders, and the same thing happened on OpenAI and other AI models. So I actually think if you don't you don't make all these AI pipeline transparent and verifiable, it's really hard to see what kind of data or like what bias that people inject into this model. Starting from what Illia mentioned, right? The data, like if you can basically poison the data, and then because AI model is a black box, you never know what kind of data is are fit into this model. So transparent data and like maybe some verification method to make sure the data are correct is necessary. And second, I think the training process also matters because everyone, if you train a model, you basically changing the weights, and it's also undetectable. So people need to figure out a way to verify that the training processes actually follow the standard process that people try to train the models. So I call it proof of training. And then also, if you have feedback that human provide, you also want to make sure that the feedback are correct, and we can call it proof of human feedback. And when you run the model, you want to make sure that the results actually correctly run on the model, which is something that we're working on right now, and we call it like proof of inference. And in general, this is more like a proof of intelligence concept. You want to make sure that the intelligence, that the AI, artificial intelligence, is actually correctly trained and correctly run by following the instructions that the AI models have. So I think speaking of open source or closed source, I would tend to think like open source as not only just as like open source the weights, is more about open source the whole process. And once you make the whole process transparent, you can reduce the bias. You can make sure everyone have access to AI. That's the second point, because we think everyone should have freedom of artificial intelligence. Just like everyone have the freedom of speaking, everyone have the freedom to publish in a book. You remember before, like people are allowed to print books, everyone need to read Bible, right? And now everyone can have different opinions, and that's kind of motivate the society to move forward. So the same for AI. If we only let one company or like a few companies control the AI models, then all the inputs that other people will have will come from this AI, which basically come from the values from those companies. And that's not good for our human society. So in general, I think we need to make the whole AI pipeline more open, transparent, and verifiable. And the second question for the business model, I totally agree with what Illia said. Like the open source doesn't mean you basically give out all the values you have. It's more about the mindset. Like if you close source, then basically you are building a SaaS model. So you need to sell the service to people, right? But if you open source it, it's more about that. You try to build an open ecosystem. That's the reason why blockchains and decentralization make sense. Because when you open source the codes, people can build and can help you to improve the security of the blockchain and like make sure that it's more performant, and everyone own piece of this ecosystem. So everyone has the motivation to stay and keep improving it. So if we can use decentralization to make build a decentralized AI ecosystem so that everyone will own piece of this ecosystem, then everyone have the motivation to keep improving this ecosystem so that we can achieve AGI on decentralization. So that's how I feel about open source and closed source.
Guess it's my turn to add something. Not a ton more to add. I mean, I agree with what Jasper just said. I don't think any coherent, cogent business model is predicated on being closed source. I think there's thousands of examples of highly functioning, extremely productive organizations that are built on open source technology. I mean, two that come to mind off the top of my head, Databricks with Spark, Confluence with Kafka. You know, these are organizations that are highly profitable that have, you know, they're revolutionizing even the AI space with Databricks, right? So I mean, I'm also super biased. I am like open source through and through, screw closed source. You know, to your point, Jasper, I think the point here is that, you know, we're all in the Web3 space because we recognize the power of community and networks. And that's what open source does, right? It is that rallying point around the technology side that brings in people, capital, effort to build out these projects. And by doing so, you know, raises up these communities that through thick and thin are going to, I think, prevail. Industry has demonstrated that. I mean, I'm going to date myself, but when I started working in enterprise almost 25 years ago, I remember being in a meeting where we were talking about implementing a new database architecture and bringing up open source and being laughed out of the room as a junior guy, like what an idiot this kid is. There's no way we're using open source in a enterprise setting. And now, you know, that is the predominant architecture and software in use at most enterprises.
Well, they're taking risk if they're using closed source because if that company goes under.
Exactly. Right? That vendor lock-in is now what used to be perceived as an advantage is actually now perceived as a risk. And I think we all recognize this, right? So I'm of the opinion, I don't know why as an AI, especially on the model side, when, you know, the reality is, regardless of the sophistication of the model, you know, does GPT-4 have, or does the GPT theories have a performance benefit over like the Llama series? Oh, yeah, maybe a small one. But the reality is, given the same context inputs, they're going to converge to the same type of inference. You know, does closed sourcing that training capability really provide a massive benefit over the long term? Probably not. So, and I don't know if you listen to like Sam Altman now, he seems to maybe be changing his tune on the open source, closed source side, at least in some of the conversations more recently. Time will tell with how OpenAI goes. But yeah, I think, my opinion, open source will dominate. I think there's also the aspect of decentralization, right? Because they're not, they can't be mutually exclusive here. I think this is an avenue that we need to figure out. And to your point, Illia, on the question, like, what are we seeing, especially this week, that the OpenAI, et cetera, are doing? They're making a very concerted effort to package all of this stuff together and make it super easy to use. And
it's a product play, right? I mean, in a way, like, the models are becoming more of a commodity, right?
Yeah, I mean, exactly. There's a race to the
commodity, but but at the same time, the products that you build on top of it or the way you create the experience is what becomes really important. I mean, zooming into this because, I mean, you guys are all kind of building in a little bit different dimensions, right? And as well, what Jasper was talking about, right? We want a way to get kind of a reproducible, you know, open source model for sources. The thing I've been thinking about is like, how do we test? How do we test the models? How do we test the training of this model? How do we ensure that indeed it's you know, correct? Or like if you retrain the new model, or if you fine tune it, did it forget things? So, I mean, I'm curious kind of diving into this because I feel it's probably one of the more important topics as this space is evolving, and especially in blockchain interactions where you have adversarial kind of, you know, especially if you're dealing with payments and money like you, Don, right? Like it's people will try to find ways to kind of exploit it. So I'm curious what you guys think. I have some thoughts as well. Alex also been working on some of the stuff.
And at that point, it's less with respect. Our focus is less with respect to like the training, and more related to the utility of the inference. And obviously, once you start paying for these things, in particular AI agents and their outputs, there's going to be questions around, was the model that was advertised actually run? Is the inference correct? So in that case, to Jasper's point, having fidelity and transparency on what those inputs are, or at least an ability to reconcile the inputs, either from a training or a context point of view to the output, I think is important. Both with just respect to what am I receiving, but also with respect to attribution, right? Like if the source information was scraped from the internet, consumed, used in training purposes, and then is outputted in the likeness of a particular artist or something along those lines, I think having the fidelity on that provenance trail to the point where you can properly prescribe attribution to those inputs, so that when you commercialize that output, it may or may not flow back to, in some capacity, that original input and the creator of that input. I think that's something that also needs to be reflected as maybe not part of the training, but definitely part of the output. And then from our point of view, things that are important, we look at like, why do we need a decentralized protocol for the payments piece, right? As we move towards this state of semi-autonomous and autonomous agents, I think there's potentially going to be a mandate from those agents that this payments piece is decentralized. Because I'm thinking about, the censorship aspect of this from a strictly payments point of view. If the payments piece is controlled by, a handful of organizations, or an OpenAI, Microsoft, or Google, Facebook, and those independent autonomous agents are outputting inferences that are incompatible with the business model of those underlying organizations that control the payments piece, the best way to censor those agents is to just shut off the payments piece. Doesn't matter if the rest of that AI agent is built on, decentralized technology. If they lack the ability to transact with other agents, that payments piece becomes the ultimate choke point. And so, I think it's a complicated question, Illia, because there are aspects where you can, try to discern the inputs versus the outputs, et cetera. But when you cobble all of these things together as an agent, there's a whole bunch of different components that you need to answer in conjunction with the verifiability and the veracity of the output.
Yeah, I can share my thoughts as well. So I think what you try to solve is, like, let's say you train on this model, and then you want other people to reproduce the same training process, right? And I think there are two. So this is basically the verification mechanism that you want to make sure that the training process is verified. There are two things. So one is like the reproducibility and determinism of these floating point calculation, or even like GPU computations. And second is more about like the high level verification mechanism design, which kind of mechanism you want to use to verify it and punish the people that don't do the right things. So first, for the reproducibility problem, we did some experiments currently, and we can show that if you use the same GPU, you use the same CUDA version, actually the result will be the same. So the floating point issue won't be a problem. But if you use different CUDA version, if you use different GPUs, the result will be slightly different because of the floating point calculations. I know people trying to do like quantization to make sure that the results are deterministic. But however, in terms of related to training, you need floating point. So, or maybe people can come up with a way to use integers to train a model, but currently most people just use floating points. So it needs some work to actually make sure that the floating point calculations is deterministic on different GPUs. We're working on that. I know a lot of other research groups are working on that, and hopefully we can solve that very soon. Second is more about the verification mechanism design. So there already exists a few mechanisms like consensus, ZK, maybe like optimistic mechanism. We also invented a new one. I will share it a little bit later. So for consensus, I think in theory it actually work, right? You basically just ask 10 nodes, and then each node will train the model on themselves, and then they will like just vote on if majority of them are honest, and by having the reproducibility, then the majority of the AI models will be the same. Then you just vote, it just pick the majority votes of the result, right? And then for optimistic mechanism, you can say like, okay, I let one node to train this model, and then other people can challenge them within a challenge window, let's say 7 days. So if another node retrain the model and then figure out, okay, these two models are actually not the same, they can break down the training process into small pieces, and then you just compare piece by piece, and you can even break it down further and finally generate a fraud proof that can let blockchain to execute, to arbitrate. So these are like the two mechanisms I think probably make sense, but it does, like for consensus, it causes a lot of overhead. So I don't think it's very practical, especially for the big models. It probably can train a random forest, or like you can train a linear regression model by doing this. I think that makes sense. For optimistic mechanism, you need to, they doesn't have pure strategy Nash equilibrium, which means that the incentive that everyone will need at least one person to verify it, the probability is actually not 100%. So it means that sometimes when you train a model, actually no one will verify, although your model training process is wrong. So we invented a new one called proof of sampling. So in general, it's more like one node generate a result, and then with a certain probability, the system will randomly assign another node to check the result. And then if the results are different, it will initiate an arbitration process, and the dishonest node will be punished. So I think like you need to, in order to actually solve these like transparency and verifiability of training process, you need these two things like reproducibility and verification mechanism.
I think I can share some thoughts from the model perspective on my end. So pretty much like, the approach we are thinking these days. So on one hand, we are developing our own model. This is an entire blockchain of graph data. So we assign properties to different wallets and different interactions, nodes and edges. Also, we train this model from learning the behaviors and learning the consequences of different behaviors, and later on we predict these behaviors based on the current behaviors of the market or the on-chain world. So on one hand, we are developing the model by ourselves. On the other hand, is we have a technique to connect with different other models. So verification means a lot. And on the other hand, we'll be thinking like developing a very generalized approach can be very hard, except maybe potentially working with Jasper, for example. But what we are thinking, what our thinking process is, rather than verifying, because at the end of the day, our GM is a large model, rather than verifying, what we do is we learn from the results. Because at the end of the day, like we know how powerful the, for example, GPT is, or how powerful Llama 3 is from using it, is from the result, right? So for example, what we are doing with our model is because we are predicting behaviors, and we develop some metrics and learning some consequences. For example, the price change of the on-chain tokens is from the behavioral change. So we learn like how accurate we can predict a token price and what's the correlation accuracy that we can develop from our model. So if, from a period of time, the model performs pretty well, it means that the model did things right because it can, develop accuracy in that way. And also for other models, like, I think there are 1,000 possibility to prove that people are doing things right. But, literally just one possibility only that if the result is wrong, which means the model is wrong. So this is kind of our thinking process of approaching things at the moment.
That's pretty cool. I think like this kind of echo with what I think about verification, because I believe the world of verification mechanism or the world of trust is heterogeneous. People used to think consensus is the only way to build trust in decentralization. Actually, turns out not. Like there's a tons of different methods that you can build trust and do verification in decentralization. And in the future, people will come out with different ways to verify the result, verify the models. And as a user, you basically can do the trade-off between the performance and security. Sometimes he wants better performance. He will choose like a verification mechanism that's more performance focused. And then if he really wants security, maybe like it's involved money transaction, then he will definitely want the high security verification mechanism.
Yeah, I mean, just to play devil's advocate, I mean, this is more of a question. I don't know the answer to this, but you raise a good point, Jasper. There's the heterogeneous nature of trust and security. And the world that I'm looking at right now with these models, people are all actively paying for them, right? I think looking at the requirements and demand from the consumer side, there's just this innate trust in what I'm getting is, trustworthy and validated by OpenAI or whoever.
But that's kind of the current state where at least OpenAI is themselves don't expect you to move money around based on decisions of the model, right? Like there's a human in the loop there who decides kind of on the output.
So my question is like, when do we think we're going to cross this real threshold where that driver will be there, right? Because the way that we're doing things right now is we're kind of separating church and state. We make sure that the settlement piece for the component that you use to interact with the agent has high fidelity to it. But then there is this abstraction because, the compute piece is taking place off chain where that verification and validation is opaque, right?
Yeah.
And it doesn't seem to be a huge deterrent at the moment. However, at some point, we're kind of, I think, all trying to front run this scenario where that does become a requirement. I'm just wondering, if everybody on here has thought about what's the timeliness for this? When does that requirement actually manifest? At least manifest at scale too.
Yeah, I think it really depends, right? Because it's the same as, as a company you trust that, your Silicon Valley bank will be there and you store your money there in that account. And then, it's all fine for 20 years until it's not. And so I think the challenge here is kind of similar, except, in AI, everything on steroids. So I think this kind of stuff will happen on steroids here as well. It's everything from a disgruntled employee or like, it's a one if statement in the code base, right? And now it's making different decisions based on the suffix of your email.
Yeah.
Or
a disgruntled Devin that you're, paying $100 for 15 minutes worth of dev time, all of a sudden, starts maliciously editing your code. Yeah.
But I think the way I think about it and because there's like few different aspects of this, right? Which is like, how do we know the model is good, right? Which there's like few pieces around that. And then when you get an inference, how do you know it came from this model, right? And so it starts indeed with like, okay, well, what data goes into this, which right now, again, for ChatGPT, even for Llama, we don't know. And so one of the things that like, it's actually really hard to debug these models, because if you don't know what data went into them, like the way to debug them properly is to have a backprop from the output that you consider incorrect on training data to see what training data have affected the most this kind of outputs, right? And so without training data, you actually are not able to debug like what are the kind of most offending data points that led to this, and you're definitely not being able to like kind of untune it. For example, if there's some specific examples that you want to kind of hit and learn, there's okay, well, let's imagine somebody does put out the data. How do you actually validate, right? If it takes like, hundreds of thousands of GPU hours to build this model, you definitely cannot expect, X number of other participants to reproduce that run. And even, you probably don't want even a single other party to reproduce a run because it's so expensive. So one of the ideas is indeed you chunk it in, like, so right now people can not just release the final parameters, but actually intermediate checkpoints when you're training, right? For example, every hour or every 10 minutes even. And then now you just need people to validate, like each independent party can validate one checkpoint, right? And green light it. And so you kind of validate every transition, but it doesn't need to be that every kind of single party validates all of them, right? You just need enough people to validate different transitions. And this is actually where I'm interested if anybody's building a economy around that, because this can actually be incentivized to, so there's different parties contributing validation for specific checkpoints. It does require solving the reproducibility of GPU computation, but I think that's an interesting kind of nugget. Then what you mentioned, Dylan, which is like, okay, well, I got the model, but like, is it actually working toward my expectations, right? So what is the evaluation? And this is one thing that I'm kind of also struggling with is like, there's a lot of kind of benchmarks, right? There's MMLU, there's all this stuff, but like they all kind of, but first of all, they're all static, right? They're not evolving, they're not adding. They usually have, like, I think I saw one of the paper had like 600 different benchmarks, right? Which is like, it's actually very expensive to evaluate a model on that benchmark. It takes like, I think, 6 hours to do just evals. So how do we actually like have benchmarks in such a way, and how do we do benchmarking across all these models? Like, is 70B model, Llama 70B better than, I don't know, some deep coder ad coding? Like, how do I know this? Is it SWE bench? Is this bench? Like, so many benchmarks. So I think that's a really interesting, I know people who are building different products, just building their own benchmarks for their own use cases, right? Usually. But then there's no like good tooling around that. So like, how do we build that? This is actually something we're looking at right now with Alex. And then you go to what Jasper was talking, especially is like, okay, well, when you do evaluate the model, how do you know this is the right output from right model? And again, like there's so many things that can go wrong, right? From, it's just different parameters that got loaded to, somebody maliciously just like reweighted tokens to blacklisted tokens to all kinds of stuff, right? To even, additional injections in the context that you didn't have, right? I mean, literally you sending to API, it can do whatever you want. They can inject context for you that you didn't have in mind. So like, how do we identify and kind of manage that? I mean, the idea of like, there's always probability that you will be checked. So that kind of gives good guarantees unless there's like a massive collusion of parties in the network. So I think like that's kind of the whole flow needs to be indeed like kind of thought through. We have evals, we have kind of probability, we have checking, evaluate, like kind of this checking protocol in a way for even open source models, fully open source with training loop. And then we go into, like when somebody's trying to maliciously now attack this, now at least you can debug like, okay, well, this is why it led to this. Like there's a training data in Reddit that somebody's like specifically posted so that later, when it became into training of the model, it actually affected the decision making. So you can actually start understanding where some of this data kind of injections happened, which like I'm assuming people are already doing them because like it doesn't cost you anything to do that. And again, if you don't know what training data is, you're not gonna be able to like detect that.
Totally agree. And I totally think evaluation is definitely necessary. And a lot of people come up with ad hoc benchmarks, but the data, like, because it's fixed, so there is always a way to train the model.
To fine tune it on the training, on the eval, yeah.
Yeah. So are you guys familiar with LMSys and Trevor Arena? Like So I think their philosophy is the best way to evaluate a model, AI model, is based on human feedback. So every time when the user send a prompt, the app will randomly select 2 anonymous models and then generate the results and send back to the users, and the users can pick which model is better. And once you have collected like millions of users' data, then you can basically do a ELO rating to decide which one is the best, which one is not. So that's how GPT-4o found out that they actually are the best right now on Trevor Arena. I think this is something that we are very, very interesting as well, because like when you try because we try to solve the inference problem, and when you want to like provide these AI models, people actually want to know like which model is the best for marketing, which model is best for code writing, which model is best for like math, etc. So having this evaluation service is a way to kind of let people know what models they want. We actually are a partner with LMSys. We're supporting their like model taught them to run models to serve people. And we think a better way to improve this is through token, because right now users cannot make any money by providing the feedback to them, right? And I mean, the philosophy in Web3 is if you contribute, then definitely you need to own or make some money out of it. So if we can use token to incentivize people to provide feedback to AI model, to this platform, then it will have more data than what we have right now, and we can have a better idea about how great the model is. And even further, if you can actually evaluate the performance of an AI model within a few hours, then basically it will like speed up the iteration loop. And every day, if you come up with an idea and then you train it, you already know whether this training method makes sense or not, and you can accelerate the improvement of AI towards AGI. And I have a question. So you talk about the data, Illia. What is the best way to check the data quality at the moment? Because like what you said, you want to make sure that no one will try to poison the data, try to poison the AI model. And what's the best way to check right now?
Yeah, I mean, I don't know if there's like a best way. There's like few different heuristics you can use to analyze the data set. The one interesting heuristic is actually by taking a model, let's say you take Llama 3, and you actually run it over the data set. So pretty much what you would do during training, but you can now see and look at the loss and identify documents which have like high loss. This is usually either spam or like it's pretty much can be one of 3 things. It's spam, it's something that's like completely new to the model, or it's something that's like weird, right? And so this is like things to look at is like, what are the things where models like really surprised by, like already well-trained model surprised by. There's also things like where the loss is very low, which probably means it's like not informative at all. You can clean that up because this is not the tokens you're going to benefit from. It's empty calories. So yeah, you can use literally the model now to score your data and understand where the kind of information is. There's also like on the document level itself, there's things that are just like unpredictable, right? So example is like if you're looking at like a New York Times article, whatever. We're not using New York Times, right? So whatever, a Reddit article or something, you cannot predict username of the user, right? That's writing it. You cannot predict, few things like that. So it actually makes sense to cap them or placeholder them, or like to pretty much modify data set to not include it, or in the loss cap it out and stuff like this. It's just like there's places where model will always stumble, because if I give you this, you will not be like, even with all the knowledge in the world, you'll not be able to predict it. So there's a lot of just things like that where as you dig into data, you can actually start understanding both how to make models better, how to reduce some of the hallucination, because like you're forcing the model to like decide on predicting something that it will never have an option to do. So you can give it option to like give, a placeholder, for example, that when it doesn't know for things that you don't expect it to ever know, and things like that. Now, there's more basic stuff. I mean, there's variety of like PageRank style information that you can use, right? If you have a common crawl, you can like, parse out URLs, build a form of PageRank. And then obviously the pages that nobody links to probably are not as interesting, although probably common crawl has less of that. And then there is an interesting question of like trustfulness, like trust and truth, right? And this is where things get complicated, right? So the example I like to use is Barack Obama is born in Kenya. If you Google that explicit phrase, right, there's a ton of websites which talk about it because it was a big conspiracy, and people love talking about conspiracy. And so how do you decide if you want to include that or not that becomes really complicated. And this is where I actually think the data curation should be at the community level, where some people will decide to include this subset of information out of this, and you kind of have non-uniform distribution of truthfulness in a way, or like subjective view if this data should be included or not. And so I think those are interesting. Like again, from a decentralized, like community-based perspective, you can imagine people like kind of almost curating different data sets, right, to train on, depending on the country, depending on community, depending on worldviews, and then having kind of different modifications of the model that's have different biases in a way based on that.
Just to dig into this a little bit. I mean, looking at this, there's the intricacies of what we're talking about, but then there's the application of it all and the consumption of the output, as well as, I think, Jasper, you bring up a really good point, again, around the attribution side and like collectivism and the community helping to train these solutions collectively. My concern is like the Web3 community, especially at this AI cross section, is doing itself a bit of a disservice. The Web2 AI space hates crypto. I think that's pretty, you talk to people that are building AIs, as soon as I mention, it's crypto based, they're like, oh yeah, hang up the phone. So I think, we need to make a real concerted effort to bridge that divide, right? And I think that some of this stems from the architectural decisions that we make, as well as like the application decisions we make. So from our point of view, one of the things that's of significant importance to us is account abstraction, right? And things like gasless payments, no pop-ups, things like that. I think what would be incredibly beneficial as a community is if, and I think, this is why we're all here, having an L1 that is like entirely focused on the success of AI and supporting the functionality side, the ease of use component would go, I think, it would pay massive dividends in both the mid and the long term. Illia, Alex, Cameron, I don't know if there's stuff that you guys can talk to on these points. I know, there's network abstraction and things like that, but are you guys seeing the same sort of thing? And then what can we do collectively to like try and minimize this point of friction of trying to get the non-Web3 AI builders to start to look at what we're doing? Because I think we bring a lot to the table. We've discussed a lot of it here that's going to be massively beneficial to the overall AI ecosystem.
Yeah, I mean, I think like from our side, there's like few things. One is, I mean, the protocol itself is designed to be kind of as user-friendly already as humanly possible. I mean, that's why Near has kind of the most consumer users on our side. At the same time, we're obviously open to work on the requirements that people have to keep adding that kind of and making it more accessible. And then on the other side is pretty much, as you said, it's kind of for us right now to prove out that this is not just, your regular crypto, but actually like, hey, here's that real use cases of using this to benefit the like AI developers as a whole, right? Either, for example, Jasper's trying to expand how much compute you can access, right? And like what types of compute you can access. Or, how do we coordinate more agents, etc. So like, how do we actually bring real value? Like we have, crowdsourced data sets that are unique and not accessible. And we can do this because we can coordinate micropayments a lot more effectively. And have people around the world actually participating in data labeling. So a lot of it is just like show the real value. I think crypto has generally been like sells the values, sells the vision, right? And then not actually show the actual value, right? And like have 1,000 users. But now it's time to like show the value and then explain the values, right? So I think that's kind of what we should be leading with is like, hey,
amen,
here's
brother.
really awesome data set, or here is like, you need compute to do inference. This is actually cheaper per token, right? Because we use all of the compute humanly possible. Or, you need this better like way to interact with this, or you need like micropayments, or you need, spin up this like system and, it's going to be expensive. How do you get users to pay for it? Well, if you set up all of the payments and everything yourself, you're going to like be in, it's super complicated. This is easier to do here. So I think that's kind of the leading here. And then like we pave the crypto way underneath. We're almost at time. So I wanted to start rounding up, but I mean, thanks guys for joining. Hopefully this was good. Again, we're testing the format, but I was pretty excited to see you all and to chat about this. Hopefully, we'll continue doing more of this, and we'll have more of kind of conversations as well on the more technical side as well. So
That was good. Thanks for inviting me.
awesome. Let's ship it.